Okay, yes. All right. So lessons learned. So again, all right. So skip. Because these are all summaries on everything we've seen. I've seen all these graphs. Well, what can we do better? How can we, for the next victim who's going to organize this, what can we change? And our first suggestion would be to have a calibration tool, or in one or another way, figure out a way we can measure or assess total rotation velocity independently of a material. Whatever we need. We see both test results. When you look at the structure buildup, you look at the flow curves, they're systematically the same reameters that are higher, systematically the same reameters that are lower, right? So can we explain that? Could that be a reason that we can attribute that difference to, right? So that's one. Two is to enhance our scope. And we've been trying to be very conservative and trying to get valid measurements and so on. But there's more and more traffic coming on the market, right? So could we have gone to more yield stress or higher yield stress material? Could we have gone to rapid stiffening materials? We should have. But again, that might be available or able to do if you have a little more time than 20 hours of physical intensive labor. If you would have 30, you could have potentially gone further, right? So initially we select the stability, make sure that we get results. And then, if you get the opportunity, you may go further than what you have. Also, if there are other reameters, you didn't have them, that would have been very useful to have more reameters in there. Reproducibility. I don't know, Denis, was you that mentioned reproducibility? We didn't do reproducibility. We just explained the IPARs, makes sense to me, why they're different. Do you want to do reproducibility tests? Do you want to test twice in the same reameter within a 5-minute time frame, but you're gonna have to empty sent back in? It has a couple of challenges, but it could be something we could have done to say, okay, let's do two quick measurements, one after the other, and see how repeatable. What's our error on the measurements? That's something we could have improved as well. Communication, again, some cases we waited until last hour to actually decide things and so on, the last day or the last minute. I think so. And maybe more importantly, you still learn on the fly. And that's a very tough one. It's a very tough one. But you get all these people running around, physical labor, getting themselves in, performing measurements, and here and there we can look at the screen and see what reameter produces which values according to the software. But I can tell you, after 12 hours in a day, on that second day, what we could have done, or what we could have done in between kind of deliveries and so on, is take a couple of results and actually analyze them on the spot. Learn from them. Because there's a couple of things we saw, what Sufyan presented on one reameter not able to catch a peak during a static yield stress measurement, and that, reduces the value of that device. We could have learned that and see there's something we can change. The measurement duration, we could have learned that pretty rapidly going in there. And that's extremely difficult because everybody's running around with pretty crazy going around with everything going on. But this could be a recommendation towards the future is if you have the time, let's pick some data out. Let's look at it on the fly, the way we're supposed to analyze it right away, have everything prepared ahead of that communication, right? To be able to learn from that and adjust whatever we need to adjust. Have a first mixture, try things out and go with the flow, right? So that could be one of the bigger things for any crazy person wanting to organize this in the future. And with this, that's the conclusion of the entire round-robin tests. So that's the only thing I have for this. So thank you.
Thank you, Dimitri. Now, one question, I would say.
You mentioned many times in your presentation.
Do you want to ask microphone?
You mentioned many times in your presentation, it's crazy person. I mean, it's not crazy. This is scientific. This is exciting. This is great. I know it's so. I encourage those who are here younger who would like to take this challenge. It's not crazy. It's about fun. It's been a rewarding experience. You guys have done a great job on this one.
It's the entire team. It's really, all people you see in the picture and all those people. It's not just us presenters, everybody around us has been really involved with this. So thank you to the entire group.
I just want to echo those sentiments. I've been on dozens and dozens of field trials, and they're $20,000, $30,000 each. So, you go through and you plan A through B, A through C, A through F, and then X happens.
Yes.
So it's always, but I think the more you do this, the more you kind of know what to plan for. reaching out to industry people, picking their brains on that stuff because we're out there all the time. Just a couple of things. So one of the things that we've done to try to do repeatability is that for the iCar, we might have 3 or 4 buckets, just not one bucket. So you can quickly go from the other. You have to figure out how you're pouring it and all that kind of stuff. And then the other question was really on air. So did you guys measure air at all?
We measure air and training, but not on the time, just only once, yeah.
Yeah, so that, I think that's a great
So,
stuff.
sorry, none of the countries were in. We did not want to go down that route.
Yeah.
It's, yes, and so we deal with it all the time, but it can absolutely affect the results, especially the loss and gain over time. So it's
That might be a good thing too.
but it's not like you need more testing, right?